So my name is Abramov. I am a space engineer at Space307, and also I'm pursuing my PhD degree in AI domain at Technical University of Munich. If you want to, you have QR code, you can subscribe to my Telegram channel, and I post some stuff there from time to time. But generally, what we are speaking today about, we have two main topics that I want to discuss. The first one is generally AI in trading. This is we'll be discussing here how our current architecture works, what is the trading cycle and how we people trade, as well as how AI trades. And what is trading AI agents? They've been quite for a while already really hyped, and we'll take a look at the architecture, nuances, and why would you like to become or create AI agent instead of usual AI architecture. Anyway, let's move on. Trading cycle. Have you ever thought how do we trade? I mean, like people. Because if you want to automate anything, you need to understand that. And in order, I usually split this cycle in a few parts. And the first part is gathering information. You have to keep yourself updated. You need to read the news, you need to read Telegram channels, you need to read XCOM platform, whatever you want. Because you need to make grounded decisions. And doing so, you can allow yourself to keep actually in the topic what is going on in the world. And then you create entry market points. So when you have news, for example, Trump imposes new tariffs, you think, okay, market would go down. And this could be viewed as an entry market point. And each news theoretically can be reversed into entry point because it somehow influences the market. You also decide which of those entry points worth investing in and which are not. And the ones that you cherry pick, you can actually open the deals and make some profit over it, or like lose money. It depends on your trading skills. And those three stages allow you to create profit, get information, and create something as entry points. And the fourth thing in the cycle is gathering feedback, because you want to understand how it all works, and you want to understand what went wrong and what went good, in order for your market strategy to adapt to new information, and in order to actually learn from your mistakes. Because you're trading like that, you become in beta, but at the same point you like just see this at your screen and you're like, okay, I'm quit trading, I will never do that again. But actually, what is better in AI is that it doesn't have any emotions and it purely follows the algorithm. And we will check out how it works, at least on our platform, and how it works generally as well. So on our platform, we have different agents, different trading agents. Each of them has unique personality and trading style. For example, technical analysis, fundamental analysis, wherever they work with long-term or short-term deals. And for example, we have here a Daddy, who is trading with low risk with Bitcoin on long-term deals. And we also have here FOX, which is more medium risk guy trying to make use of short-term deals. And basically, they all follow the same pattern, because this is basically describing the general trading algorithm. So our AI agents do basically the same steps as usually people would do. So they gather information, they create entry points, and then open the deals. And they as well also try to adapt their style of trading based on the feedback that they have from the market. And in our platform, we have implemented all of those features, and we will take a look at the first two, which is gathering information and creating entry points. Our architecture looks the following. So we have plenty of different resources. We have, for example, financial news websites, Telegram channels, Twitters, and we have AI model that is capable of analyzing all of those. It also has knowledge database, and for example, to keep the model itself in the context what is going on. and it implements some sort of algorithm on how should it analyze the news. And then it produces the deal setups. So basically, okay, we have Trump imposing tariff news, and the model decides that, okay, it would be short with a 10% take profit or whatever. And here you can see how our users usually see that. So we have a box and we have a news. Okay, there's a Bitcoin wallet that got activated. And here's like a setup for you. Do you want to invest in that or do you want to skip this? And we also have open deals system that decides which of those deals should be invested in. And pretty much it follows the same algorithm. So we have deal setups as input of the model, and we have some knowledge databases, we have infrastructure for that, and we have a model 2, which is basically another algorithm that tells how to compare different deal setups to each other. And at the end, it decides, okay, I need to invest in that, I need to invest in that, and those deals are really bad, I should skip them. And the problem with that is that even though those algorithms look alike, they still consist of several services distributed with their own architecture. So you have to actually support each of those services. If you need to, for example, create a new database source, you have to adapt each of those services to this new data source. And it is quite time-consuming, since we have to distribute our human resources into investing into several pretty much the same services. And why do we want to shift into AI agent schema is because instead of supporting multiple systems, we can actually create a single entity that is capable of various actions, and we wouldn't need to invest into several architectures, rather we would just support only one. And for that, we actually chose AI agent schema because they become quite popular right now, and it is also, from technical point of view, quite useful if you have multiple AI features on your product. Let's take a look at AI agents and current trends. Probably you've already heard about any of those, or maybe not. But unlike AI chats, AI agents possess knowledge and they're capable of autonomous actions. So, for example, AI chats been already in the market for 5 or so years, and AI agents is the next step of these chatbots. Not only do they can chat with the user, but you can ask, okay, I need some sort of, travel booking, or I need some action to be made. For example, create an email and send it to another person. And those autonomous actions, I think that those are the core functionality that helps AI agent to be distinct from AI chats, because usual AI chats cannot do anything autonomous, and they pretty much just for chatting. And this is one of the most popular AI agents in financial sector. It is HPT, and usually what it does is, okay, it gathers all the news, and it tries to predict and analyze what each news would be telling you about. And it tried, it would try to analyze the news, and basically it is 24/7 influencer, which tries to analyze the news and give you the core idea of what is going on in the world. And if you want to build an agent yourself, there's actually so many frameworks that you can use. There's LangChain, True AI, AutoGen, ElizaOS, and each of those frameworks, they have some functionality which is core functionality for this framework, and but they also have their own drawbacks. So when you're trying to build AI agent, you should really consider what are your purposes and why you need that. Because not every framework might suit your needs, and that's why you should considerably think what do you want from a framework and what it should do for you. For example, LangChain. LangChain has been in the field already, I don't know, for 5-7 years, and probably many of you are aware of that already. And it has vast integration ecosystem, which means that it has many features already implemented. So, for example, rack systems, some integration specifically for AI agents. It also has a large community and documentation, but at the same time, there's no default connectors to social media. So, for example, if you want to create a clone of XBT, you have to come up with something different, because you would either need to implement a connector to social media, to Twitter or Telegram yourself, or to choose another framework to extend LangChain. And also, from what I've heard from many users, LangChain is rather a collection of demos held together by duct tape, rather than a normal framework, because of the naming conventions, because of the function, some of them really strangely implemented. And yeah, if you want to use that in production, you have to really give that a double guess whether you would need that and whether it is useful for your own needs or not. Crew AI is mainly implemented in order to sustain a team of AI agents. So, for example, if you have a task of, I don't know, creating some application, you can create AI agent, could be like product manager, front-end and back-end developers, whatever you need, like AI analysts, and they would work together in order to fulfill the task that you have proposed. And it is really easy because my framework is focused on communication between different agents. It is really easy to run multiple agents at the same time with the same task, but with different roles. And it is basically created for coding and close coding tasks, because as well as with the previous framework, there's no default connectors to social media, and it is basically not, I wouldn't say it's AI agent in the general sense, but it's mostly like you want to create a task and you want it to be completed, and you try to do that via creating a crew AI team. And it is also, since there's already so much implemented, it is also an abstractions which may not always suit your needs. And if you want deeper control over what that agent would do and how it is implemented, you should probably look into another frameworks like LangChain, because there you would need to, you basically have more control of what is going on. There's also Autogen, which was created by Microsoft. The really outstanding feature of that is that it has no code studio, so you don't even have to code in order to AI agents to work, and you can basically create simple agents using just like graphical interface. But we all understand that no coding means that you have even less control of what is going on and how flexible it could be. So I think for some quite plain and straightforward agent, for example, take that, go to this website, do the following, and when you have already algorithm which could be quite easily generalized, it is okay. But for something really diverse and specific, I don't think this is the best choice, although they provide plugin extensibility, including MCP, and you can write your communication via this framework. And the last but not least is ElizaOS, which we're discussing today, I think, as the main hero, because one of the reasons is that it is really easy to configure and to run. It is rather than a template, which already provides you with some functionality, but I would say that you have even less control rather than other framework if you had used them. It also provides you with various open source connectors and plugins, and it has from scratch already connectors to Twitter, Slack, Telegram. If you need to connect it to Bittrex for a reason, probably you might even implement it yourself and try to publish it, and it would work. And what is the weaknesses is actually memory. Not only injection attacks, but I have also stumbled upon that you cannot provide dynamic memory in the current implementation, which also restricts you from many use cases when you need to dynamically update your memory. And this could be really tricky if you want to use that. And documentation is relatively undetailed, and for me, for example, I had to go into the function implementation directly to see what is going on there, because there's like no documentation relatively that function. And also, as a drawback, I'd say it is implemented only on TypeScript. So you have to either code on TypeScript, or you have to use cursor as I do. Probably it's not generating some really unprotected code. But let's dive deeply into AI agents with ElizaOS. One of the reasons also why I chose that is that you can actually run any agent with only 3 lines of code. You have to just install from GitHub repository, create your environment, and then provide it with some OpenAI keys, for example, and you are ready to go. And as any AI agents, Eliza provides you with a possibility to create memory and rack. This is all implemented from scratch, and you don't need to actually think about that. How things to be done and how do you work with that. It provides you with actions. So those are specific features that could be callable. For example, I don't know, analyze this website, and you have a function that is dedicated with a specific algorithm that analyzes the website and tries to conduct some actions in order to, I don't know, book a ticket, or if you need to create the top 10 current news on this image, or whatever. And it also provides you with plugins. So those are connectors to various websites and tools, starting from Twitter, Slack, and Telegram, and then ending up with some financial tools, for example, money transferring from one account to another, or I don't know, something with cryptocurrency. It can create crypto coin wallets and also work with that. And it also provides you with a configurable characters, so you don't need to think how to implement it yourself. So you have distinct characters. You provide how they should behave, and all other things are already implemented and embedded in the system. So you don't need to actually worry how your prompt should look like. Apparently, you still need to do some prompt engineering in order to make the character really lively, but mostly it is not that sketchy as you usually do with the ChatGPT, for example. And Eliza framework looks like that, so it might be a little bit overwhelming at first, but we will go one by one. So generally there's like memory system, as we have already discussed. It stores all the conversation history, it stores all the knowledge that you can provide, and relationship data, as well as vector embeddings. So vector embeddings are currently used for rack system, and relationship is used mostly with the user interactions. And there's action processing, so you describe each action that model can do. For example, I don't know, use calculator, or use email, or go search in the Google. And before applying something, there's intent recognition systems, which try to predict, based on the user input, which action needs to be taken. for example, user asks me to send an email, okay, I'm gonna do that because I have an action which tells me that I can use email with the following parameters. And there's also context processing. Context is basically all the memory, all the history, and everything that could be related to the current conversation, including previous history, message history, and as well as rack output results, which might be relevant in the current case. There's also output, which is response generation by using various AI models, including open router models, ChatGPT, Claude, Google, or just you name it. There's like 30 or something API that you can use, as well as your own models if you want to. And the thing is that everything is platform specific. As I've already told, it can go from scratch, interacting with Slack, Telegram, and whatever. So it is rather abstraction, and the core functionality stays the same. So it doesn't really matter which source which platform you use, because you can implement the interaction logic for Bittrex, Telegram, or whatever, or your own application. For example, if you want to create a chatbot, you just tell and implement some code how it should interact with your platform, and the core functionality will be untouched. And yes, with AI agent, we can create a consistent and unified representation for our services, which is specifically useful if you have multiple of AI features that you need to sustain. And our current architecture is moving towards this one. So we have AI agent, we also have memory rack context, which includes information about user, which includes previous messages, and actions. So basically this is the ElizaOS framework, and what differs from previous architectures is that we don't have several services. We don't have several infrastructure that we need to sustain. We only have one of that. And as input, it takes either from chat with the user or from our internal system prompts and data, and then predicts, for example, and creates entry market point, or vice versa. It analyzes the news and tries to stay in touch with the user. Or if the user asks a question in chat, it also has the same functionality as described here. So it could go with action, it could make use of the memory and rack system, and could, for example, explain the user what is going on currently on the market. But there are some nuances that you should consider, even though it all might seem really cool if you want to reduce developers' need, of sustaining services. It is not always possible. For example, in our case, it was not possible to provide real-time answers with actions. This one of the nuances that you should consider. And for example, we have a technical agent. It tries to analyze the graph and tries to predict the prices. As you can see, it can produce the levels, it can produce some patterns, and analyze RSI market influence on the current price. But the problem is that it all takes some time to work. For example, in order to analyze only one single picture, it takes from 5 to 7 minutes, because it needs to, first of all, find all levels of resistance and support. Then it would try to draw some patterns, and then it would pull up some analysis. And if you provide technical analysis as an action, you might face up the following issue. For example, user comes and they say, okay, how's Bitcoin doing, or how's gold doing, or how's, Fortune 500 doing. And the problem is that it would apparently overload the system, because many of those requests could not be processed at the same time, and each of that requires some time and each of those requires some resources. And apparently, user is not going to wait for 5-7 minutes in order to receive a feedback from AI agent that is somewhat real time. And what we came up with is we have not the action of technical analysis, but we rather have a scheduled technical analysis. For example, every hour our model analyzes all the assets that we have on our platform, and then it saves it into agent memory. It is something up to date, and there's not a huge delay into that. So you can still, it is still might be relevant, not might be, but it is like 99% still relevant. And when user asks, okay, AI agent, what is going on with the any asset you name, then AI agent is not performing the action, rather it takes the action result from the memory directly. By using this architecture, we don't overload our system, as well as we provide a real-time feedback, which usually users will appreciate when they don't have to wait for several minutes. And wrapping this all up, there's several conclusions. First of all, using AI agent could really simplify your system. If you have multiple AI services that you need to sustain, and you need to put some effort into supporting them. And but at the same time, you still need to think how you would implement that, because it is not always possible to provide some actions in real time. As well, you can face some nuances in the framework usage. For example, as we've already discussed in ElizaOS, there's no way to provide it with dynamic memory, which would be updated on the fly. And you still need to think, okay, what are our purpose and what are our constraints when you're trying to come up with a framework and AI agent. And unified model is apparently way much better than several services, because you don't need to implement multiple data connectors. You have only one point where you need data and where you need to analyze that. You just provide different prompts, and you provide, for example, different actions in order to achieve the same results as with the several architectures of various AI features. And generally, AI agent is current trend, so probably if you tell on your conference that we're using AI agents, that would be kind of cool and hypey, but I'm not sure. And this is generally all the conclusions. If you have any questions, you're free to ask them. Thank you for your attention.